Welcome to Space Titanic Expectation, feature engineering for binary classification. Today, we'll explore the data and perform a part of essential feature engineering to prepare for our journey into predicting the fate of space travelers aboard the Space Titanic. Well, our first step is to load the dataset and delve into feature engineering. We'll explore basic statistics, distributions, and handle missing values, outliers, and data format conversions. Mm, Let's begin by loading Space Titanic dataset using Python's pandas library. You can identify the number of rows and columns with shape method, and here you can get 8,693 and 13 columns, and the outline of dataset with upper 5 rows from head method. You can check the columns and the rows. Well, next, then let's identify the columns with object type features in our dataset. You can have object type or numerical number type features here. The result is home planet, cryosleep, cabin, destination, VIP, and name. We have 6 columns as object type features. And now we investigate object type columns for unique values in each column, getting insights into potential categorical features. And as you can see, home planet has 3 different values, and cryosleep 2, cabin has destination 3, and VIP 2 different values. And they also have value and AN here, 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 and here. It means a known value, and we call this missing values too. It is important to handle these missing values when you analyze your data. Let's check next time how to handle them. And we also have cabin and name columns. And we can check that they have more than 6,000 distinct values, so that I think it's not good to use them for categorical data. However, we can transform cabin column to be categorized and get some meaningful information from it. So let's check how to do that in a moment. And next step is to find out more information of our dataset. I'm going to visualize missing values using a heat map. Before that, you can check the numbers of missing values in each column with its null and sum methods. Every column without transported here has 0 missing values, and others, they all have approximately 200 missing values on average. And we can see them by visualizing missing values using a heat map. It helps us understand the extent of missing data in our dataset. And now you can see the missing values with white lines for all columns except transported. We need to consider how to handle these values for analyzing dataset more accurately and generating a model to predict the result. There are several ways to handle missing values. Since we have quite a lot of them each column, it would be possible to replace them with other values such as mean, median, or other categorical values for them. Well, now descriptive statistics part. Descriptive statistics of numeric features provide a snapshot of the central tendencies and spread in our data, allowing us to check for outliers in each column. This emphasizes the importance of examining descriptive statistics. You can assess the count without missing values here, as well as the mean, standard deviation, minimum value, and first quartile value, median, third quartile value, and the maximum value for each numerical column. Notably, we observed that approximately three-fourths of the spaceship's passengers are 38 years old or younger, indicating a predominantly young demographic. However, there are older passengers too, as evidenced by the maximum age of 79. The remaining columns here, room number, room service, food court, shopping mall, spa, and wheel deck. Analysis reveals that the majority of passengers did not spend money on these entertainment options, with only a few opting for substantial expenditures. You can check that even median values of all the entertainment options column, they are 0. The substantial difference between the minimum and maximum values suggests a dramatic range of spending. Initially, considering the maximum values as potential outliers, it is important to find evidence supporting their status as actual outliers. For now, let's keep this aspect in mind and proceed with our analysis. Next, check the columns for the numeric features in list format, and we can get here age, room service, food court, shopping mall, spa, wheel deck. Exactly here, same with the columns here in descriptive statistics. And now visualization time again. We employ box plots to detect outliers in numeric features, ensuring our model's robustness. And you can check the distribution of data with the lines and circles here. And storing and visualizing categorical data enables us to grasp the distribution of feature values, crucial for our analysis. Now, let's dive into key analysis insights based on visualizations, shedding light on features such as home planet, cryosleep, destination, and VIP status. Here are pose and the graphs. Well, the first analysis for home planet. In the case of Europa, there are more instances of being transported, while for Earth, there are fewer instances of being transported. So we can choose Europa, Earth as categorical values for home planet. And the second one is for cryosleep column. In the case of true, there is a significantly higher number of instances being transported, approximately 5 times more. On the contrary, for false, the instances of being transported are lower, approximately a twofold difference. And the third part is for destination. In the case of TRAPPIST 1E, there are fewer instances of being transported, while for 55 Cancri E, there are approximately 300 more instances of being transported. For PSO, the instances seem nearly the same. And the last graph for VIP column. In the case of VIPs, there is a very slight decrease in the number of instances being transported, while for non-VIPs, there is also a very marginal difference with slightly more instances of being transported. From this analysis through bar graphs, we can say home planet, cryosleep, destination can be the variables that can affect results of dependent variable transported, especially cryosleep, because the difference of values between true and false based on transported is obvious. And now we're back again to numerical columns. We investigate correlations between the transported variable and numerical features to understand potential relationships and multicollinearity. And you can see here, there seems to have slightly weak relationship with the transported variable in the order of room service, spa, and wheel deck. However, there is not a significant correlation between the features. And let's visualize the histogram of passenger counts by age based on the transported status. It provides insights into potential patterns. Before finding out the potential patterns related to age column, I'm going to store values of the column age by transforming type of missing values to float type and created bins to categorize ages for analysis. Under 20 and from 20 to 40, over 40. So you can see we have new column named age the bar cat here. It has 3 different values here. Check them. And now we'll enhance our dataset by generating new columns based on categorized age values above, providing a more detailed exploration of age-related patterns. And here is what I've done for it. And you can check here. We have now another 3 more columns. And the values false or true. False or true. Let's visualize count plots for each age category column based on the transported status. This will give us insights into how different age groups are distributed among those who were transported and those who were not. You can check here. To the third. Okay, fantastic. We've expanded our feature set, delved into more detailed visualizations, and uncovered intriguing insights. Join me in the next episode as we continue to refine our model for the ultimate Space Titanic prediction. Thanks for watching this video. Bye bye.